Using the axes below, we can sketch the graph of y equals sine x for values of x between 0 and 360 degrees. You must label any important values on both axes. So the sine x graph essentially is going to be like a wave, okay? So it's called the sine wave, and we're going to see the wave going a bit like this now. So in order to label our values here, okay, on our x-axis we need to go from 0 to 360. So we do that by going in a scale of 90, okay? So perhaps, because we've got about, say, 12 centimeters there, and go every 3 centimeter, okay, we can mark off. So 3, 6, 9, and 12, okay? And we're going to mark there 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So we're going from 0 to 360 degrees here. On our y scale, well, if you remember a moment ago, I sort of roughly showed you what the curve is going to look like. It is going to be like a wave, okay, like that. The peak, okay, of the wave is going to be at 1, and the trough is going to be at -1, okay? So at the top here we'll go for 1, so maybe we'll go 3 centimeters high as well. So we'll mark that there, that will be 1, and we've got 3 centimeters down here, so -3 there. So the highest value, as I said, will be 1, the lowest value will be -1. So in order to draw this curve, okay, or this sine wave, we need to know the values of sine at each of these points, okay? Now if this was in the calculator exam, you could literally get your calculator, okay, and you could type in sine 0, okay? So sine 0 equals, and you get 0. So when the angle x is 0, the value of sine will also be 0, okay? If we go then and look at what 90 degrees is, we get 1, okay? So that's at the crest of the wave. So if I go up to 1 here at 90 degrees, mark it there, okay? And then similarly then, if I do 180, so sine 180, we'll get 0. And then if I do sine 270, I get -1. So at 270, let's go 3 centimeters down, so -1 here. And then if I do sine 360, I get 0. Okay, so if this is in the calculator paper, then you can use your calculator to sort of remind yourself where these important key points are in the curve. If it's not in the calculator, if it's a non-calculator paper, you're going to need to just remember the shape of this curve, okay? So I'm going to now draw the curve through these points, okay? And it's important for you to remember that this is like a wave, yeah? So we can't go straight. We don't want to see straight zigzag. It needs to be curvy and looking like a wave. So just make it a curve, so we're going to go around like that. And then we can turn the paper around. It's always good to turn the page around to draw this. Okay, you can turn it upside down, whichever way is easier, so you can actually get this looking like a wave. And there you've got your sine wave, okay? This is only a sketch, okay, so it doesn't have to be perfect. It's important that we get our scale values written on the graph. It doesn't matter if it's a little bit shaky, okay? The main thing is that you get it looking like as best as you can as a wave, but not using a ruler. So then underneath then it says circle the value that is equal to sine 30, okay? So we can see then we've got sine 60, sine 150, sine 180, sine 210, sine 330. So which value is actually equal to sine 30? Now we would be doing this part maybe without a calculator, okay? So this part here wouldn't have a calculator involved. So we would look for where 30 degrees is on the axis, okay? So you can see there roughly a third of the way along, yeah? So you don't have to get your ruler out as such, you just need to go roughly about a third of the way along. That's where 30 degrees would be. And what you need to do then is to have a look where that value is on the curve, okay? So we need to go upwards until we hit that curve, and it's going to be here. Okay, so essentially the value of sine 30, okay, can be read from our scale if this was drawn accurately. But they don't want that. They just want to find an equivalent of sine 30. Okay, what other value will also have whatever sine 30 is here. Okay, and by the way, sine 30 is actually a half. Okay, it's exactly a half. But what other value on the curve would also have a value of a half? Well, if you notice across here, there's another value here which also is at the same height. Okay. All right. This value here, and we would need to then determine which one of these down here would best match that particular angle there. So the one that's closest, you can see obviously then, is 150 degrees. Okay, now you could use some sort of simple symmetry here, and we can appreciate when we look at this curve that angle there of 30 degrees, okay, is going from the origin across to 30, and it's exactly the same as going backwards from 180 here to that value here. So if we're going across 30 to get to this point on the curve, and it's like going back 30 to get to this point on the curve. So if you take away 30 from 180, you get 150.